All right, welcome to Area and Estimating with Finite Sums. And how I'd like to do this is to talk about distance traveled. So we're going to say, how do we measure distance traveled? And this is going to give us the basis of how we can find area under curves. But first of all, let's kind of talk about what we're going to do here. And we're going to talk about a car traveling down a road, and the following are estimates of its velocity are found. So basically, okay, here's my time in seconds. At 0, 3, 6, 9, and 12 seconds, somebody took speed measurements or velocity measurements, okay? So it's going 10 feet per second here, 20, 25, 30, and 32. So this car is speeding up. And someone took these speed measurements, we could say with a speed gun, at these intervals, okay? Now let's first of all do some basic stuff. So I'm going to be writing all in here. So the first thing is, I do know that distance is rate times time. So if I know how fast I'm going and I know how long it took me there, I can tell you the distance. Again, we can say the rate in this case is the velocity times the time, because velocity is a vector quantity and it has direction, magnitude and direction, but that's our rate. And if you look, what we have here is we have time and we have velocity. So if I multiply these two, I'm going to be able to find the distance. Okay, so there's our basics. So I want to show you at the bottom here, before we go through all this, that I've graphed, or there's pictures of graph, and this is the time, and this is the velocity. Here's the time. It's the same graph. So you're like, why do I have two? So here I actually plotted each of the points and then put a curve through it. Okay? Time times velocity, sorry. So basically we're looking at the area under the curve. So we basically can say that the area under the curve that's below, all right, so we're going to say the area under the curve will give the distance traveled. Okay? And a way to find the area under the curve is we can approximate it by using rectangles. So let's put that here, the area under the curve can be approximated by the sum of the areas of a collection of rectangles. Okay, so first of all, I want you to notice that these are points on the curve. And then we're going to draw some rectangles so that this will make it more understandable when we're trying to estimate it. So here I have two, the same exact graph, and we're going to estimate this using some rectangles. So here is a rectangle. We're going to make each rectangle be the same width. And if you look at it, I'm going to do some carets here. If you'll notice, I went from 0 to 3, 3 to 6, 6 to 9, 9 to 12. So I can say my change in my time is 3. So basically that's the width of my rectangles, is I can make each one 3 wide, okay? And if you'll notice, I have 1, 2, 3, 4 rectangles. So we're going to say n is going to be 4. Now this is going to come later, but we have 4 rectangles. And I usually do that by counting my carets here. So I've got, okay, from 0 to 1. Now if you'll notice, the number of rectangles I have is 1 less than the columns, because you have to have the end starting on one of them. See, the end could be here or here. It doesn't matter, but I've got 1 rectangle here, 2, 3, 4. So it's 1 less than the columns. So let's kind of draw this. So here's the first one. So if I do 1, 2, 3, 1, 2, 1, 2, 3, they're all 3 wide. 1, 2, 3 wide. 1, 2, 3 wide. So there's my delta. So here's 3, 6, 9, and 12. We can do that here too. 3, 6, 9, and 12. Okay? Now, how we draw these rectangles can be different. So I'm going to show you, I'm going to do, well, I'll keep it in black and we'll change it, is I'm going to start and draw this first rectangle using this point, the left part. So I'm going to go from the left, come over, and go down. There is a rectangle. Then this rectangle here, I'm going to start at this point, and I'm going to come over, and I'm going to come down. So there's a rectangle. I'm going to start at this point, come down, come over. Start at this point, come down, come over. So I made 4 rectangles using those points, but I used the left. See how I use the left point to come over? The left point to come over. Now we're going to shade these a little bit, and when I shade these, let me change my pen settings here, a little bit different color. I usually shade them doing this. So like I'll go like this first to shade this one, and then I shade this one this way. And I shade this one here. Don't scribble and fill it all in, but you know, just make it so it looks like you're shading. Because if I knew the area of these rectangles here, I could kind of estimate by taking base times height. So here's my time right here, and here's my velocity. If I multiply that, base times height for all these rectangles and adding them up, I'd have an estimate. And if you'll notice, this one would be underestimate, if you will. So this would be an underestimate because the rectangles are less than this curve. So you're missing right here, you're missing like this area in here. So it's not going to be perfect, but it'll be pretty close. It's underestimate. Now how I did this, the other thing I want you guys to know is I actually used the left part. So this is going to be, I use the left hand side, so we call it LHS, the left hand side, or if you will, the left end points. I use the left end points to come up with these rectangles. Okay, there's a lot of ways to say this. So I use my left end points, or I call it the left hand side to come up with this. And it looks like it's going to be an estimate. And it's going to be underestimate because it looks like it's not going to be as high as it should be. So now I'm going to change the color here, and I'm going to use red here. And I'm going to draw these rectangles using the right hand side. So we're going to use the right hand side here, or the right endpoints, if you will. And we're going to draw the same rectangles, but instead I'm going to use the right hand side. So when I do this, draw that rectangle, draw that rectangle, draw that rectangle, and this rectangle. Okay, now when I do this one and shade it in, I see that this is going to be a little bit of an overestimate. This will overestimate the distance because it's a little bit above the curve. All right? So let's bring this back to black so you can see what we have here. So let's look what I have. So here's my velocity times my time. So I have the same width, okay, because that's the interval of time, but now I've used the right hand sum, or if my right hand or right end points, and in this case it's going to be an overestimate. Okay, so let's go back and look at the points here to see how we can actually come up with that. Now we can actually go through and do this, but we do know that our interval is 3 seconds and we have 4 rectangles. That's what we use for both. The upper bound, or the right end points, as we just did, right end points, or we call the right hand side. So you can see this right hand sum, upper bound. So we're going to basically take all the sum of all those rectangles. So we know this is a high estimate, okay? This is how we did it. We're going to do, first of all, you're going to start here on the right hand side, because that's what we did down here. See? We started at 3 and we went over. So watch. I started at this point right here, this graph, and I went over. So I am going to start basically on the right hand side here and say, okay, my rectangle is 3 wide, and I started at the 20, it's 20 high, plus it's 3 wide the next one, and it's 25 high, 3 wide, and it's 30 high, 3 wide, and it's 32 high. Now let's look at this where I got those 20, 25 is. See, this is 20 right here, and I basically said this is how high this is times this is how wide. Then I used how high this one was by this wide, and I went through and used my right hand side there. That was the height. See how I went there? And notice I started right here because it's my right hand sum, or I use my right endpoints, and I end here at 32. So there's 1, 2, 3, 4, 1, 2, 3, 4. Those are my rectangles, and they're all 3 wide. Okay? And when I add all that up, I say I traveled 321 feet. That's my estimate. The other way you could do this, because I'm multiplying all these by 3, I can actually factor out the 3 and just say 3 times 20 plus 25 plus 30 plus 32. This will also end up to be 321 feet. Okay? So right there is our estimate. Now we know this is a high estimate. It's an overestimate because see how the rectangles are a little bit over here. Okay? Now let's do the lower bound, or the lower estimate. So that's going to be over here at the left. So when we do, we're going to start here at the left, and we're going to end one short, because this is how tall. Now let's look at this. This is how tall it is here. Then I'm using this one here, and then this one here is how tall this one, and so we don't need the last one. So again, we're going to do the lower bound, or the left endpoints, or the left-hand sum. There's a lot of ways to do this. So we're going to do the same width of our rectangles, but now we're going to use the left hand. So we're going to start here and stop here. So the left-hand sum goes from here to here. The right-hand sum goes from here to here, because you got to have one of the endpoints. So we're going to use 10, 20, 25, and 30, and we're going to stop one short. So it's going to be 3 times 10 plus 3 times 20 plus 3 times 25 plus 3 times 30. Those are the height of all those rectangles, and when I add those all up, I get 255 feet. Again, I can write this as 3 times 10 plus 20 plus 25 plus 30, and that is going to give me 255 feet. And that is our underestimate. Okay, we knew that was going to be an underestimate. So they will call this right here our lower bound. There's another word you hear. And here they're going to call this our upper bound. All right? Now, so I've estimated that I've traveled in this time here 25. So the distance traveled in that short amount of time, that's traveled, not D. I don't know why I did that. The distance traveled is between 255 feet, and my distance is in the middle here, to 321 feet. All right? And remember, the distance traveled, sorry, I keep doing that, is the area of all these rectangles that we have here. We actually multiplied the area and added them all up, and we did it here. So this is our overestimate, and this is our underestimate. And I want you to recognize, and it's equals the area of the triangle, excuse me, rectangles, area of rectangles. And the other thing I want you to recognize, that if I did more frequent measurements and made these rectangles skinnier and skinnier and skinnier, then you would have a more closer to the curve, and that's what we're going to do on the next example. So I'm going to stop this video, and then we'll do that on the next one.